This is Algebra 2 with trig. 1a, 1a. We're going to graph absolute value functions. These are going to have transformations with them. We're going to use Rst graphs. So first we're going to talk about a parent function. So when we talk about the parent function, there is a table that we can make. So we have x and y. We'll put our 0, when we plug in 0 to the function, the absolute value of 0 is 0. The absolute value of negative 1, what is that? Is 1. Negative 2 is 2. 1 gives us 1, and 2. If we plug 2 into this function, we would get the answer of 2. If you're not sure about those, you can always go to your calculator. You can hit the math button. It's right here. Go over to number. And you'll see the first topic up there is absolute value. So you could say the absolute value of 0. And we get the answer of 0. Math, over to number, absolute value. You could say negative 1. You'll see you'll get a 1. Math, number, absolute value of 2, positive 2, is going to give you a positive 2. So if you're not sure, you can always use your graphing calculator, as long as it's allowed on the quiz or test. It should always be available for your homework. The graph, when we plot this out, and it's going to continue at that pattern. It's going to make this V shape. It's not quite a parabola. That is the absolute value graph. So I like to label the graph next to it. The graph has a vertex at 0, 0, which is also considered the origin. Let me get my other letter in there. Origin. The slopes of our lines, we have a positive one slope and a negative slope. And we can tell that this parent function is opening upwards. The domain is all real numbers. Those are the x values that you're allowed to plug into your function. Notice how the graph is slanting to the right, the graph is slanting to the left. It's covering 0, it's covering 1 and 2 and 3 and 4, where x is 1, x is 2, x is 3. It continues on. It would continue on for the x values forever. You can plug in any x value to this. That means all real numbers. There's a symbol we can use, which is an R with a double line in it. It almost looks like an A and then an R. All real numbers. And the range is whatever y values that we're covering. We're covering from 0 and going up. So where y is greater than or equal to 0. You can use interval notation, where you plug in your smallest number, comma, the largest number you're going to hit, which is any number up. You can see the graph goes up, and it'll go up forever. It can hit any y value going up. Infinity is our idea there. Because it can touch 0, we put a square bracket, and you can never really get to infinity, so we put a curved bracket, a parenthesis. When we graph, here's a translation of an absolute value. the absolute value of x minus h plus k. That's taking the parent function and it's translating it h units horizontally, right and left, and k units vertically. The vertex is going to be at h comma k. The h value is the number inside the absolute value, and the k value is always the number on the outside. Sometimes I have it in front, but it's out. Not just in front, but it would have to be added or subtracted. You'll see that eventually. But it is a k value. Now notice this here is always going to be opposite. That's always the opposite sign. So if this is x minus 3, then your h value is 3. If it says x plus 3, then it's going to be a negative 3. So what that means is when we add a number to the outside of the graph, that's what affects it of going up and down. A positive number is going to move it up. A negative number is going to make it go down. On the inside, it's going to be the opposite of what we think. A positive number, adding a number to x, is going to make it go to the left, and subtracting a number is going to make it go to the right. So that's going to be opposite of what you think, or opposite of what you might think. That's the h value is going to be the opposite. Let's try it. Now in this section, I would like you to use the Rst format. We start out with the parent function. And we learn from the top of this page that the parent function of the absolute value graph looks just like this. And we label our equation. And then we're going to be able to translate. We take all of our values 1 unit to the right and 3 units up. 1 unit right and 3 up. 1 unit right and 3 up. So when we do that, we have y equals absolute value of x minus 1 plus 3. And when we compare it with the parent function, the parent function is translated 1 unit to the right. Remember, that's opposite of what you might think. And it's translated 3 units up. The k value will be exactly what it says. Plus 3 means up. Minus 3 means down. So for this one, we start out with the parent function. And that's your graph, y equals absolute value of x. Now go ahead and pause the video and you try graphing out absolute value of x plus 2 minus 5. Take all your points and translate them to the left 2 and down 5. So we're going to go to the left 2, down 5. And always write the equation of your graphs. So how does it compare? The parent function is translated 2 units to the left. Remember, it says plus 2, so that means it actually goes to the left. Five units down. It's not the left because of the absolute value, but it is the left because it's your h. And in your original formula, it's x minus h. So the h had to be a negative 2 for this to say x plus 2. When we're graphing with an a value in front, that's going to give us a vertical stretch. That's going to stretch out all the y values. You multiply the y value by the absolute value of a. It's considered a coefficient to the absolute value. This is going to affect the opening of the graph. The absolute value of a is greater than 1. So if this value is greater than 1, we're not worried about the sign, then it's vertically stretched. It's going to look something like that. If it's less than 1, we're not worried about the positive or negative. It's going to look like that. If it has a negative, -1 or -2/3, it's going to be opening downwards. A negative is going to make it open downwards, and then it could have the stretch or the shrink, all depending on if the value, not the negative, but the value is less than 1 or greater than 1. On the flip side, we're pointing out the same thing we talked on the other side. So when we multiply by a number in front of the absolute value, the number affects just the y value. So you can multiply the y value by that a value. And when we multiply by a negative, the graph is going to go down or open downwards. When you multiply by a positive, of course, it opens upwards. When you multiply by a negative, it has to get reflected over the x-axis. Some like to say reflected in the x-axis. Whatever word you like to use. So I'm going to start out with the parent function. We're still trying to use the Rst way to graph these. So this is y equals absolute value of x. And you multiply the y value by your a value, by 1/3. So 1 times 1/3, 2 times 1/3, and 3 times 1/3. You could do 4 times 1/3, you could do 5 times 1/3. And the same idea over here. And this is y equals 1/3 absolute value of x. In our comparison, we have the parent function shrunk by a scale factor of 1/3. We want to use the correct math terms. So you have to say parent function, you have to say scale factor, You have to use the word shrunk. You could use shrink. Okay, here we're going to start out with the parent function. So that's y equals absolute value of x. That's what we have for the parent function. Then we see the negative. This is the first negative we've had, which gives it a reflection. So it's going to flip it over the x-axis. So now we have y equals negative absolute value of x. And then we're going to take all our y values and give it a multiple of 2. So instead of going down 1, we go down 2. Instead of going down 2, we go down 4. Instead of going down 3, we go down 6. So this is going to become y equals negative 2 absolute value of x. Okay, here's some reviewing. This talks about our RST some more. Transformations. Transformations means all of the RST. The reflections, the stretches and shrinks, and the translations. The parent function is the y equals absolute value of x. The reflection is when your a value is less than 0, when it's a negative number. That means it's going to open down. There is a vertical stretch when your a value is greater than 1. That means the graph is going to open upwards. It's vertical stretch, so it's actually going to be tighter than normal. And it's going to be a vertical shrink when your a value is less than 1. It's going to look wider than normal. It shrinks. It pulls down the numbers vertically. If you take your parent function and you multiply by a number less than 1, you're going to pull it down, you're going to shrink it, which makes it wider. You have your translation, which we're going to translate horizontally, h units, and we're going to translate vertically k units. So in here is always the opposite of what you think. Not because of the absolute values, but that's the way the h value works. The k is exactly the way it looks because of the plus. This is opposite because of the minus. So we're going to start out with the parent function. We're going to get y equals absolute value of x. That's our parent function. We're going to shrink. That means multiply the y values by a half. Comes down half as far. Same thing on the other side. Instead of up at 2, we're going to go to 1. Instead of up at 3, we'll go to 1.5. 4 goes to 2. 5 goes to 2.5. So here we get a y equals 1/2 absolute value of x. And then we're going to take all of those dots that we made and we're going to translate them 2 units to the left and 3 units down. Two units to the left, 3 units down. So that's going to be y equals 1/2 absolute value of x plus 2 minus 3. The parent function doesn't have any reflection, but it does have a shrink. So we could say is shrunk, trying to keep our English correct, is shrunk by a scale factor of 1/2, comma, and translated 2 units left, 3 units down. That would be our comparison. We start out with the parent function. This is the graph y equals absolute value of x. We're going to do a reflection to it because it has the negative. That means we're going to have a reflection. So that equals y equals negative absolute value of x. Then we're going to take those and stretch all those numbers by 3. Instead of going down 1, we're going to go down 3 times that amount. Instead of going down 2, we're going to go down 3 times that amount, to 6. Rs. So that's going to be y equals negative 3 absolute value of x. And then we're going to translate that, each one of those points, 1 unit to the right, because it's negative 1 to the right, and then up 2. To the right 1, and up 2. To the right 1 and up 2. Take all the points that we have, so this is y equals negative 3 x minus 1 plus 2. Oh, our comparisons. The parent function is reflected, because of the negative, it's reflected over the x-axis, stretched by a scale factor of 3 translated 1 unit right, 2 units up. Now we're supposed to write the equation of these absolute values. So let's take a look at where this vertex is at. It's 1 to the left and 2 up. So 1, 2. Actually, -1, right, because it's to the left. So your h value is -1, your k value is 2. So if we're going to use y equals a, absolute value of x minus h plus k. A is your slope, and if you notice, we're up 1 over 1, up 1 over 1, so it's a slope of 1. This is our equation of an absolute value with transformations. So 1 is our A value. You could put a 1 in there if you want. The absolute value of x minus. Now if we have an h value of -1, we should use parentheses. Plus k plus our 2. Now that can be cleaned up. We really don't need the 1. So absolute value of x plus 1 plus 2. You could type that into your graphing calculator to see if it produced the same graph. There's a math button on your graphing calculator, and that gives you this menu, and you arrow over to get to number, so you see absolute value and hit enter. You can type in what you think the equation is, x plus 1. Then we move over to type in the plus 2. Hit your graph, and you'll see a wide graph. Let's change we'll go to zoom number 6. And that's just standard. Take it back to a normal graph, and this looks a little bit more like it may here. Okay, so same place. Gives you an idea of using the graphing calculator, and you can check your work, at least while you're doing your homework. The calculator is not always available during every test and quiz. Over 2 and up 3. That's our vertex. Our slope to the right is down 1, or down 2, positive 1. So the slope is -2. Down 2 over 1, down 2 over 1, down 2 over 1. Be sure the slope is consistent. So we can write our equation as negative because it opens down, 2 because that's our slope, absolute value of x with a -2 because it moves to the right, and a +3 because it moves up. To the left, 3 down. So y equals, with a slope of up 1 over 2, so it's a half. So it's a half, not -1/2 because it's opening upwards. X minus 2, it's always the opposite of your h value. -3 because it's dropped down. Last question. Write an equation of an absolute value function with a reflection in the x-axis or over the x-axis, a vertical stretch, and a translation so that it is in the 4th quadrant. First quadrant, second quadrant, third quadrant, 4th quadrant. So we need to be in the 4th quadrant. We need to reflect over the x-axis. Let's see, write an equation of absolute value with a reflection. So it's got to be going downwards. It's got to have a stretch. So it's going to be something like that. So our equation could be y equals, it has a reflection, so we know it's negative. It has to be a stretch, so it's got to be a number bigger than 1. It's got to get to the fourth quadrant, so we got to move to the right. So it's got to be x minus a number. And then to really get into the fourth quadrant, we have to drop down some amount. Any amount you want. Everybody could have a different equation. You don't have to match mine. It could be a different equation, but it has to be minus a negative a value. It's got to be x minus h, and it has to be a negative k. Good job, everybody.